Have you ever really looked at an IV bag and wondered what's inside? I mean, it just looks like a bag of water, right? But it's actually one of the most powerful tools in all of modern medicine, designed to restore a super delicate balance inside every one of us. So today, let's dive deep into that hidden inner ocean that keeps our bodies running.
Okay, let's kick things off with a fact that might blow your mind. About 60% of your body is just water. Yeah, more than a half of you right this second is water. It is by far the most abundant thing we are made of. So that leads to a pretty obvious question. If we're mostly water, where is it all? I mean, it's not like we're just sloshing around. So how is it all organized in there? Well, to answer that, we need to understand our body's fluid compartments. And you can think of it like a hidden inner ocean that has very, very specific borders. It turns out all that water in your body is split into two main zones. First, you've got the intracellular fluid, or ICF for short. That's all the water that's locked inside your trillions of cells. Then there's the extracellular fluid, the ECF, and that's pretty much all the water outside the cells, just kind of bathing them. And get this, the split between these two isn't even close. A massive 2/3 of all the water in your body is intracellular. It's tucked away safely inside your cells. That means only a third of it is on the outside, in that extracellular space. Here's a really cool way to visualize this whole thing. Think about it from an evolutionary point of view. Life began in the salty ocean, right? So when our ancient ancestors moved on a land, they basically had to bring the ocean with them. Our cells are like these little bags of potassium floating in our own personal ocean of sodium. And that chemical difference is absolutely critical. Inside the cells, the main players are potassium and proteins. But outside, in that mini ocean, it's all about sodium and chloride, salt. These different chemicals, which we're going to call solutes, are what drive literally everything that happens next. So, how does this all work? How does the water know where to go? Well, its movement between these different spaces isn't random at all. It follows one simple, unbreakable rule. And that rule has a name: osmosis. It's this fundamental process where water moves across a barrier, like the wall of a cell, and it always goes from a less concentrated area to a more concentrated area. It's nature's way of trying to balance things out. It's super simple, really. If you've got a less salty side and a more salty side separated by some kind of barrier, water is always going to rush toward the saltier side to try and dilute it. So this is it. This is the big one. The golden rule you have to remember for this whole thing is this: water always follows the solutes. Wherever those particles of salt and sodium go, you can bet that water is right behind them. Now, in a healthy body, when everything is balanced, the concentration of all those solutes, you could call it the saltiness, is perfectly equal inside and outside the cells. This is our body's happy place. No major shifts of water, everything is just humming along. But, of course, that perfect balance doesn't always last, does it? So what happens when we throw a wrench in the works? Let's look at a couple of everyday examples. All right, scenario 1. We've all been there. You sit down and crush a big bag of salty potato chips. It seems harmless, but it actually kicks off a dramatic chain reaction inside your body. Okay, so watch this. That salt gets absorbed from your stomach into your extracellular fluid, that outer ocean. All of a sudden, the ECF is way saltier than the fluid inside your cells. So what happens? The golden rule kicks in. Water gets pulled out of your cells to try and dilute that salty fluid. And the result? Your cells literally shrink. Okay, now for a totally different scenario. Let's imagine you're out in the heat, sweating a lot, you're losing tons of fluid, but not a whole lot of salt. For the most part, you're losing pure water. So, when you lose pure water from your ECF, the salt that's still in there gets more concentrated. The ECF becomes saltier, not because you added salt, but because you took away the water. And believe it or not, the result is exactly the same. Water gets yanked out of your cells, and again, the cells shrink. So, when your cells are shrinking, or in other cases, maybe even swelling up dangerously, how do doctors fix it? Well, this is where that simple IV bag becomes the hero of our story. The fix is an IV infusion. But, and this is a big but, it's not a one-size-fits-all solution. There are 3 main types of IV fluids, and choosing the right one is absolutely critical because each one is specifically designed to do a very different job, all based on that principle of osmosis. So let's break down the toolkit.
First, you have isotonic fluids. They're balanced just like your own body fluids, so they don't really change cell size. Then you have hypotonic fluids. These are more diluted, less salty, so they cause water to move into cells and make them swell. And finally, you have hypertonic fluids. These are super concentrated, more salty, so they do the opposite. They pull water out of cells and make them shrink.
Okay, so now that we know the tools, let's see them in action. Doctors use these like precision instruments, matching the exact right fluid to the exact right problem to bring the body back into balance. So check this out. If a patient is losing both salt and water, maybe from something like diarrhea, they get an isotonic fluid to replace exactly what they lost. If they're dehydrated from sweating, where they lost more water than salt, they get a hypotonic fluid to push water back into those shrunken cells. And in a really rare case, like someone with dangerously swollen cells from drinking way too much water, they get a hypertonic fluid to carefully pull that excess water out. All right, so let's boil this all down. What are the key things to take away? First, remember, most of your body's water, a full 2/3 of it, lives inside your cells. Second, never forget that golden rule. Water always, always follows the solutes to the saltier side. And finally, an IV bag isn't just salt water. It's a precision tool engineered to manipulate osmosis and bring your body's inner ocean back into perfect balance. So that simple bag of fluid hanging by a hospital bed, it holds the power to command your body's inner ocean. And it does it all based on a single, elegant principle of physics. Pretty incredible when you think about it. Not so simple after all, is it?